So that's all for me. I welcome Leon now to take on his part of this presentation.
Thank you, Andrew. So my name is Leon Kraversky, and I'm the CEO of Soltell Systems. I must also mention this is the second event we are co-organizing with Blu Banyan after a successful event last year, all aimed at providing our experience and the technology edge to the solar community. This year we would like to speak about how solar performance assessment can help with finance. I will start with an overview of what's happening in the global PV market and touch a little bit about the US as being an extremely important part of it. So we're roughly talking about 1 terawatt of solar deployed worldwide, and this is growing at an exponential rate. About 38% of this market is decentralized PV, which is from residential and small commercial to community and industrial scale. Roughly, it's typically defined as something below 1 megawatt, and it's also typically on the rooftops. On the other side, we have decentralized, which is utility scale PV. The utility scale is typically something which is larger than 10 megawatts, and everything in the middle is called industrial. So industrial, in some definitions, can be defined as utility when it's closer to 10, and when it's smaller on the roofs, it behaves as the decentralized one. Now, US is about 12% of the global market already, and we're talking about 2.5 million systems out of about 20 million worldwide. And those two worlds are quite different in terms of how we know if they work well and how the finance works for those both segments. And I want to talk about this differentiation. Please, next slide. So we divided to 3 tiers, I would say. One tier is what we use for utility scale. It's the top tier. It gives the lowest uncertainty, the methods which are utilized there. They use the techniques which are considered the most precise. It's performance ratio with temperature correction, and it's typically utilizing high-tier equipment and accurate modeling. On the other side, tier 3, we have the centralized PV, and we have monthly modeling and comparisons to actual production with meters. It's the easiest and the low-cost one, and it's the most common also in reality. Now, in the middle, we have something which can be suited for both. This is a kind of generic, and this is utilizing remote sensing. Those techniques have developed over the past decade, and they provide a reasonable 5 to 10% uncertainty. So this is quite good for the centralized PV in most cases, but it's certainly not getting to the level of tier 1. In terms of costs, it is about in the middle, but it's getting lower. So it's a kind of partial solution for the centralized assessment problem. Next slide, please. Now, what is the problem with the most common one for the centralized PV? And we're talking about modeled monthly averages. So the problem is that most months are not like the months which used to be average historically. And we saw this quite radically in Spain this March, when the solar irradiance plunged by 50% compared with historic averages, even though, you know, the plants were fine in most cases, but in financial assessment and financial reports, they underperformed by 50%, which doesn't make any sense. And this is not something unique. So I'm in the solar industry for 14 years, and I've seen those comparisons being quite inaccurate over time. So how can you build something to finance a facility and then to compare the reports on the monthly level if this is something which is not accurate. Now, there is another problem with this, is that we are essentially utilizing renewable energy to mitigate climate change, and climate change is happening. So we are essentially relying on historical averages to assess the future performance, even though we know that the climate is changing. So it's a kind of oxymoron. Now, this work by Sunspec Alliance and the San Jose University tries to put an order on the performance assessment from the high tier to the low tier. And we can see that, for example, the high tier is something which is applied to utility scale typically, and it's a high cost technique. On the other side, a low tier is something which is utilizing monthly averages and comparing those with inverter energy production meter. That's the common one. Now, in the middle, we can, of course, find remote sensing techniques, which are providing a kind of solution. But also, I would say that the standard weather stations, which are built on industrial scale PV, do provide, for example, performance ratio, which is not corrected with temperature. So it can give about 5 to 10% accuracy. Only correction with temperature can bring you closer to 5%, but you must apply also proprietary algorithms, a more advanced software, which is typically utilized only for utility scale to get the really good assessment of performance, like is done again for the utility scale. Now we see a diagonal blue dashed line, and this is the cost-effective range, which is conventional. And this is the reality we're facing today. But actually what we would like to see is to bring the ability to assess performance for commercial and residential scale to the same tier as is done for utility scale. And we must do it at sufficiently cheap cost to make it feasible. Next slide, please. So let me summarize. We have high quality but high cost techniques with local weather sensors applied for utility scale PV. When combined with proprietary algorithms, you can reach an uncertainty level of 2 to 5% without reliance on any weather variation, of course. And that's the golden standard for the utility scale. On the other side, we have the low quality but low cost techniques with a simple model, and then just comparing those with meters. But the weather variation is making it quite inaccurate, and essentially what you get is quite bad results, which are not as much qualitative, not as much quantitative, but rather qualitative. In the middle, we have remote sensing techniques, which do provide some sort of solution for the centralized PV. And those can bring you to about 5 to 10% uncertainty. But on the other hand, the cost there of decreasing doesn't improve the uncertainty level. So we have been researching all those techniques and trying to apply this to the spectrum of PV sizes of different segments, and basically fit the best possible technique, which in theory could bring high quality at low cost and to the best of our ability, make it without modeling, without sensors, and of course also without satellite dependency, while reaching the same level of uncertainty. So what is the future essentially, where we want to go? So Solar Power Europe, which is the largest and probably most respected association in Europe, recommends essentially not utilizing monthly averages, but rather availability of a plant, calculating it to reach the required performance estimate. And this requires more complications, but it is possible. On the other side, Sunspec Alliance look at industrial and utility scale and recommend to use performance ratio, PR, with temperature correction, instead of a simple PR calculation, which is not that accurate. Now, here is something I want to expand on what we can contribute to this. So we have developed our own sensorless algorithm, which doesn't require hardware and neither remote sensing, with the support of the Israel Innovation Authority. And we proved it to reach an uncertainty level of 2 to 5%, which is pretty much tier 1 for any facility, anywhere. And we also developed the intactness indicator specifically for the decentralized segment, which is useful for the operation and maintenance segment. We can also provide a soiling assessment to any plant without any extra hardware. And of course, as I mentioned, we do not need modeling, no sensors, and we don't rely on satellite data. So what we can do with this data is basically make it available to anyone connected to our software or through API. And we are now making it compatible with the orange button standard, which is something which Cliff will expand on later. And now we're working together with Blu Banyan for integrating this data into financial reports. If you're interested to know more about advanced solar performance analytics for decentralized PV, you're welcome to contact me.